As mathematicians, we're taking derivatives using the definition of derivatives, the long and tedious way. They did notice that there were patterns that existed with sines and cosines. So based on those patterns, they came up with some rules. So you will be able to, at the end of this lesson, you'll be able to use sine and cosine rules to find the derivative of a function. Let's first of all look at the rules. And actually, before I even look at the rules, I'm just going to look at when it says up here d dx of sine x, that's asking us to take the derivative of sine x. So I'm going to just start with the visual representation here. So let's say this is the sine function, looks something like that if you recall. Okay, and we're trying to find the derivative of this function. So let's go ahead and see if we can do that. When I'm taking the derivative, remember we're just finding the slopes of the tangent line, so I'm just going to try to on this one, just highlight a few of the slopes of the tangent lines. You'll notice this one, if I were to draw the slope of the tangent line at this spot, it's going to equal 0. If I found the slope of the tangent line, let's say I was going to find it right here. If I drew the tangent line, notice it's a negative slope. I'm going to say it probably has a slope around -1 or something like that. And then down here, you'll notice that if I drew the tangent line, there's a slope of 0. And then if I come up to here, you'll notice that we have the slope of +1 this time. And if I come back here in the middle, I get a slope of 0 once again. And then if I'm over here, if I drew that tangent line, it once again has a slope of -1. And then if I come down here, draw the tangent line, it has a slope of 0. And then if I came over to the side and drew the tangent line, I would notice that it has a slope of 1. So now what I'm going to try to do is recreate this, and actually let's draw what does that derivative look like then. So notice at this spot my derivative was 0, so it had a y value of 0. So I'm just going to go ahead, it does that. Okay, there's my point, 0. Okay, notice a little bit farther over it says I have a slope of -1, so I'm going to go down to -1 and put a dot there. I hate that will not let me put a dot. Alright, so we've got a dot there. Hopefully you can kind of see that dot. There we go. And then over here there's a slope of 0, so I'm going to put 0. There we go. There's my dot. Yeah, 0. Okay, then up here, when x equals 0, it looks like I have a slope of 1, so my y value is going to be 1. So there we go. And then up here, my next value over, my slope is 0, so I'll have a slope of 0 there instead. And then over, the next thing over, I have a slope of -1, so again, I'll go down to -1 and put a point. You can see that hopefully. And then again, I have a slope of 0. And then once again, I have a slope of 1. Okay, now let me just go ahead and connect those if I can see what's going on here. Okay, and if you look at that, if you look at the derivative, hopefully you notice that that actually is exactly what the cosine function looks like. So when we take the derivative of the sine function, we actually get the cosine function. That's where that rule came from. Okay, similarly, if I take the derivative of the cosine, if I were to go through this entire process again, so here's the cosine function. Okay, and if I went through that entire process again, just like what I did on this first example, when I graphed the derivative, what I would end up getting would be the opposite of the sine function. That's exactly what I'd get when I did that. So the derivative of the cosine function is the opposite of the sine function. So let's do a couple examples using that. So if it asked me to find the derivative of this first example, 2 sine x plus 3 cosine x, first of all, since there's this plus sign here, we're going to take the derivative of each part separately. So if I'm going to find f prime of x, first of all, 2 is a constant, so it's just going to tag along for the ride. The derivative of sine, we just found out on the previous slide, was equal to cosine. And then for my next part, the derivative of 3 cosine x, the 3 just tags along for the ride again. The derivative of the cosine of x we found was equal to negative sine x. That is my derivative. So it's mostly just remembering that rule to get you to where you need to be. Okay, the next example, find the derivative of y equals 5 plus sine x. Again, since there's a plus sign, we'll take the derivative of each part separately. So y prime equals the derivative of 5, since it's a constant, is just 0. And then the derivative of sine we found out was equal to cosine x. So my derivative is equal to cosine x. Right? My third example, we have g of t is equal to pi cosine t. The biggest thing on this one, please remember that pi is a constant. So once again, it's just going to tag along for the ride. So g prime of t is equal to, let's put a pi in there because my answer will involve a pi. The derivative of cosine we found out was negative sine. So it will be negative pi sine t. And that would be my answer. Just one caution as you're doing this problem, please do not write it. Some people will go, oh, let's bring down the pi, and then the derivative is negative sine t. But what I'm going to think that you mean here, even though you probably don't, is that this is pi minus sine t. We definitely don't think that. It's actually multiplying, so don't do that. So hopefully now you can find the derivative using sine and cosine.